Hello, welcome to Dr.K.Liu Math channel. Here is a question from student. This is the DSE, HKDSE M2 question. And the first one is about the mathematical induction to prove this statement. And first I let the statement Sn, let Sn be the statement. Summation from 1 to 2n, 2 times r minus 1 over 2 to the power r equal to 3 minus 4n plus 3 over 4 to the power n for all positive integer n. And for n equal to 1, left hand side is r from 1 to 2. Which is when r is 1, which is 1 over 2, when r is 2, which is 3 over 4. The sum is 4 over 4. And for the right hand side, put the n equal to 1. The result is the same, 4 over 4. Therefore, S1 is true. Assume SK is true, i.e. This statement I copy and change the notation n to k. And then for sk plus 1, the left hand side should be this one. The upper limit is k plus 1, 2 times k plus 1. And we can divide it into 3 parts. One part is the summation. From 1 to k, and then plus extra 2 terms. The next term is 2k plus 1. The term 2k plus 1 is 4k. Put 2k plus 1 into out, 4k plus 1 over 2 to power 2k plus 1. And when put the r equal to 2k plus 2, the numerator is 2k plus 2, and the numerator is 4k plus 3. And then this is by the assumption. We can copy the assumption into the result and plus the later the other 2 terms. And also I make the numerator to be same. Here I change the numerator to be 2 to the power 2k, and then I make the common denominator, which is plus the denominator should be 2 to the power 2k plus 2. So therefore, the first one should be times 4. The second part is times 2. The third part remain the same. And simplify the denominator, which is 4k minus 7. And change the denominator into originally 4 to the power k plus 1. And then minus, factorize the minus sign, and the numerator is 4 times k plus 1 plus 3, which is actually the case of sk plus 1, the right hand side of the sk plus 1. Therefore, sk plus 1 is true. by the principle of mathematical induction, Sn is true for all positive integer n. Okay, this is the first part of this question. It is normal level. Then now I change to second part. The second part is using the result A to evaluate this one. And for the part 1, summation out from 401 to 600. We can divide it into out from 1 to 600. 600 is 2 times 300. And minus summation from 1 to 400. 400 means 2 times 200. Now I can apply the formula above. For the first one is apply the n equal to 300. 3 minus 4 times 300 plus 3 over 4 to the power 300. And this second part is 3 minus 4 times 200 plus 3 over 4 to the power 200. And simplify this one, and I think you cannot use a calculator to finish the result. I only express it into the 4 to the power of something. The numerator is 4 to the power of 300, and for the numerator which is first, the 3 is cancelled, and this is minus 1204. 1203. And for the second part, which is minus is plus, positive is 803. But after make the common denominator, here we have 2 times 4 to the power 100. It is the final result. For the second part, which is the hardest part, most hardest part of this question. First, I observe which is the structure of this summation is quite different from this one, because the numerator, here is the numerator 2 to the power r. Here is the denominator. It's not easy to do. And for the this one is this one. 2001 minus 2r, but here is 2r minus 1. Therefore, I only focus on one thing. I want to change 2001 minus 2r to the format of 2s minus r, 2s minus 1. Therefore, by using this guess, I put s equal to, I put 2s minus 1 equal to 2001 minus 2r. And here s is minus 100, and it should be 1001 minus r. Yes. Therefore, I change this one and put this one s equal to 1000 minus 1, and then for r equal to 401, s should be 1001 minus 401 is 600. Oh, same. Okay, same the upper bound of the original summation side. And for r equal to 600, s equal to 1001 minus 600, 4010. You only change the upper limit and lower limit of the side. Therefore, the S equal to 600 to 401, and this for this one is equal to 2s minus 1, and R is equal to R is 1001 minus S. And factorize the here I make the common factorize the common factor at 2s minus 1 times 2 to the power 1001 over 2 to the power minus s summation. And exchange the upper bound and lower bound 401 to 600. And factorize this one outside the summation side. Oh, this is positive. And finally, we can observe that it is exactly the format of question in 1. This is exactly the format. Therefore, and we can copy this result into the next step. 2 to the power 1001 times minus 1203 plus 8003 times 4 to the power 100 over 4 to the power 300. And cancel the numerator and cancel these two. We can achieve the result 2 to the power 401 times minus 1203 plus 803 times 4 to the power 100. Yes, this is final result. I hope that guys can enjoy this question. Actually, this question is not easy, and there is so many technical steps to overcome the problem. Okay, this is actually the characteristic of the exam in Hong Kong, in HKDSE. The question look like very simple, but actually it is very technical. Yes. Okay. And if you found this video is useful, please subscribe my channel. My channel is the Dr.K.Liu Maths second channel. Okay. Bye bye.